Hello everyone. In this topic, we are going to understand tools and technologies used in data engineering. Now, let's look at the tools, what we generally use as a data engineer. There are many tools, but we can divide them into the categories like ingestion and processing and storage, transformation, orchestration, monitoring, and CI/CD. So let's try to understand different tool categories in the data engineering stack. Let's go one by one. First one, data ingestion. Generally, the data ingestion is nothing but to collect the data. For example, you can take Kafka, Event Hub, AWS Kinesis can be used here. And next one, data batch processing or batch data processing, which is usually for daily or hourly jobs in which where we will use Apache Spark, ADF, or Databricks as such. Next one is a streaming data processing, particularly for live data. Here we can use Apache Flink, Azure Stream Analytics, AWS Kinesis, etc. And next one is data storage, where we keep the data with the help of like Azure Data Lake Storage Gen 2 or Snowflake, BigQuery, Redshift, etc. Data orchestration, where we used to schedule the workflows of a different data pipelines and the respective jobs. Here we will use Airflow, Microsoft ADF, I mean to say Azure Data Frame, Azure Data Factory, and Prefect. The next one is data transformation. In order to perform the data transformation in a clean and a modification of the data, how exactly it is required for the analytics, we can use either SQL, Pandas, or PySpark, DBT, Informatic. There are a lot of tools actually here even, okay, rather than like a plain programming stuff. And last one is a monitoring and the CI/CD. In order to verify, test, and deployment, we will use this part like Grafana, Azure Monitor, and GitHub Actions can be utilized here in the monitoring and CI/CD. So all these things will work together in order to create a complete data pipeline. So now, what are the data ingestion tools? The first step in any data pipeline is ingestion. Data ingestion, which will collect the data. So here, as I said, the Kafka, which is an open source and very powerful, that can be used for the real-time data. And whereas coming to the Azure Event Hub, which is a cloud-based version of Kafka, which can be used in Azure. Likewise, AWS Kinesis, in the where you can use this one in the AWS cloud platform in order to collect and process the data streams. Likewise, we have something called the stream sets or Apache NiFi, where you could use those tools like a drag and drop for building any sort of data flows. So you can choose any of the tool based on your requirement. For example, like in a railway system, live train positions can be sent to Kafka every 10 seconds so that applications can show where the train is right now currently. Okay, this can be considered as an example. Now let's go to the batch and streaming data processing tools. Let's now look at the tools which is used to process the data either in the batch or in the real time. Now the batch processing tools comes with like Apache Spark, which is used to process the big data in chunks and works on a cluster particularly. And next one is Azure Data Factory, which is specifically used to build and run the batch pipelines in the Microsoft Azure platform. Databricks, which provides a Spark as a service where you can write the notebooks like in Python or SQL and schedule the jobs very easily. You will have this Databricks available in the Azure and also AWS as well. Next one is the stream processing tools, Apache Kafka Streams, where you can work on the real-time processing using the Kafka topics. Okay, you might not aware of what exactly is all about a Kafka topic, which we could understand later. And keeping that one apart, Apache Flink, which is a powerful engine that can be used for the real-time analytics by implementing the windowing technique and aggregations and all. Likewise, now let us try to understand Azure Stream Analytics. Coming to the Azure Stream Analytics, which is used in Azure to process the streaming data with the help of the SQL-like syntax. Now, if we can understand with a real-world example, you take any retail chain, like any retail chain like Reliance Fresh, particularly in India, located, okay, or Walmart, okay, which is very famous in across US. This kind of retail chains with 1,000+ stores, daily sales from all the stores must be processed in batch using Databricks to update financial reports. But customer feedback and delivery status is processed in real time using the Azure Stream Analytics. So alerts can be sent immediately if delivery is delayed. Okay, so now let us go ahead with the another topic like storage and query engines. After processing, we need to store the data and allow the others to query it. So for the storage tools, you can use the Azure Data Lake Gen 2, which is going to store the structured and semi-structured and also the unstructured data efficiently, particularly for the big data purposes. When it's come to the Snowflake cloud data warehouse, which is very scalable, easy for the business queries as well. Coming to the Google BigQuery or AWS Redshift, these are all managed services under the cloud for data warehousing, and also these are fast and quite serverless, where we don't require to worry about managing them on a server. Next one is a query engines. Query engines you can just count on like Azure Synapse Analytics, which will run the SQL queries on big data, which are stored in the data lake. And next one is a Presto, which is an open source tool for querying directly on the files, like a Parquet files or ORC. Okay. And next one is going to be like even you can consider if you wanted to understand like in a cloud platform, AWS Athena. Okay. Likewise, Hive, which is used for the batch querying in the Hadoop systems exclusively. Okay. Let us take an example here. Let us take a telecom company who will store all the call records and recharge history in the data lake. For billing teams, they use Snowflake to generate monthly usage reports. And for product teams, they use Presto to query clickstream logs stored as Parquet files. Or otherwise, they can use even AWS Athena to query the clickstream logs stored as per the Parquet files that were stored in the background. If it comes to the whether it might be a cloud or open source, identification of these tools are very important. Now let's come to the transformation tools, which will help us in converting the raw data into the clean and useful data. The common tools are like a PySpark we will generally use, and which most prominently we will use the PySpark or Pandas. If not, data build tool is there, which is called which is famously known as a DBT. And or otherwise, we do have the SQL query language in the Synapse or the Snowflake that which can use. So DBT, like which is a SQL based tool to transform the data inside the data warehouse itself. That includes even testing, version control, and documentation. Everything will be available inside. And whereas coming to the PySpark and Pandas, the Python tools can be used to write the Python scripts in order to clean and reshape the data. And whereas coming to the SQL and the Synapse, where you can write, if you wanted to write a ELT logic directly inside the warehouse, you can do it. That is very simple to use even. So these kind of transformation tools, if you just if you try to understand in a real-time environment, you can take a travel booking platform like a IRCTC or Indian Railway platform or something else, which receives the raw bookings and the respective logs from 50 different partners they have associated with already. They use either PySpark or a DBT or otherwise anything else like scripting to standardize the booking formats and fix the missing codes and create a unified reports for operations. All this happens inside the Snowflake, which will reduce the ETL time by almost 60%. Finally, let us try to understand what is a monitoring and CI/CD. Why do we require to much worry about these DevOps tools? Yes, we require to understand why these DevOps operations also require to be very well known for a data engineer. Once pipelines are live, we must make sure that they run properly and are easy to update. This is where the monitoring and CI/CD comes into the picture. Now let us try to understand the monitoring tools. There is something called an Azure Monitor or the application insights from the Microsoft Azure point of view in the cloud, which will particularly track the failures and the performance and different errors that they come out in the Azure pipelines as well. And next one is a Grafana and Prometheus. So these are used to create the dashboards and real-time alerts. And whereas coming to the DQ, which is used to validate the data quality, like checking duplicates or null values and all. Coming to the CI/CD tools, GitHub Actions, GitHub or GitLab CI, which will be used as a CI/CD. I'm just repeating again. Coming to the CI/CD tools, we have GitHub Actions or GitLab CI, which will help automate testing and the deployment of the code. Or otherwise, you can go with the Terraform or Pulumi, which can be used as an infrastructure as a code that is used to create the pipelines and storage with the code. Likewise, the DBT Cloud, where you can test the DBT models automatically before you publish them. So this is how that we can understand the monitoring and the CI/CD tools usage as a part of a data engineer. Why? Because here, let us take any sort of analytics company. Let us take a healthcare domain. All the patient data pipelines are monitored using the Grafana. If a pipeline fails or a field has too many null values or alerts that are sent to the Slack, the code changes in ETL jobs are deployed using the GitHub Actions, and the infrastructure is deployed via Terraform. So this is how the tools can be utilized in any sort of a real-time oriented data analytics company. So at last, like coming to the tools by the cloud platform and their differentiation. When it comes to the data ingestion, Azure Event Hub, AWS Kinesis, GCP PubSub can be used. And whereas coming to the batch level, Azure Data Factory, AWS Glue, and GCP Dataflow can be used. When it comes to the stream, Azure Stream Analytics, AWS Kinesis Data Streams, GCP PubSub plus Dataflow can be used. When it comes to the storage, Azure ADLS Gen 2, I mean to say Azure Data Lake Storage Gen 2, AWS S3, and GCP GCS can be used. And when it comes to the warehouse, Azure Synapse, AWS Redshift, GCP BigQuery is there. Orchestration, when it comes to the orchestration, Azure ADF pipelines are there. And Azure ADF pipelines are none other than the Azure Data Factory pipelines. When it comes to the AWS, we do have the step functions. When it comes to the GCP, we do have the Cloud Composer. So this is how it is. Like we can connect all these kind of stuff. Like when it comes to the AWS, let me say like a bank which is storing the data, like a customer data in AWS S3, but processes transactions using the Databricks on Azure. So this is nothing but like a multi-cloud platform. So they run cross-cloud data pipelines using the Airflow, which is again open source, and querying everything from the BigQuery, which is from the Google. So they can use different kind of tools in order to ensure the entire data pipeline management creation. Now we can take a real world example as such, like Kafka for the real time order ingestion for a kind of an online retailer like Amazon or Flipkart. Okay, where you can use the tool like a Kafka for real time order ingestion. Okay, different orders will comes in, right, for every application. Whereas like Azure Data Factory, which will be used for scheduling the batch data sync from the partner systems. And whereas the Databricks plus Delta Lake can be used to clean and standardize the data. Apache Airflow can be used to orchestrate the workflows across the systems. DBT plus Synapse can be used for modeling and the business logic. Power BI, which is used for the dashboards to track daily sales and the returns. So what exactly the business is getting benefited from this? With this stack, which is going to deliver the automated sales insights every 15 minutes with a rollback capability and strong testing using the CI/CD pipelines. So In this particular topic, we have learned clearly about all the tools and technologies that we require to understand as a part of the data engineering. Okay, so this is the end of the topic. Thank you.